Hi guys, welcome to my channel. In this video, we are going to analyze a question is about structural analysis. The question will be analyzed due to the moment distribution method. And let's analyze the question. First, I'm going to find the fixed moment. Okay, what is my fixed moment? Fixed moment from B to from B to C, because it will just be from B to C. From B to C, that will be WL square. What is W? 8 times L square is 6 square over 8, and the result will be minus 36 kilonewton per meter. 36 kilonewton meter. Why it's going to be negative? Because it's the direction of the fixed moment. Okay, so let's find the stiffness factors. Stiffness factors from B to A. That will be 3 EI over 5, okay, 0.6 EI. And from B to C, that will be 3 EI over 6, and it will be also 0.5 EI. And now let's find the distribution factor. I can write them here, sorry. And distribution factor from B to A, that will be 0.6 EI over 0.6 EI plus 0.5 EI. Okay, and this is going to be 6 over 11. When I subtract from the 1, then I'm going to obtain that distribution factor BC will be equal to 5 over 11. Okay, now I find that. You know that if it is pin connection and a roller connection, it ends connections. That will be 1. I guess you remember. And this is going to be 6 over 11. This is going to be 5 over 11. And now I have distribution factors. And also I have my fixed hand moment as minus 36. And this is going to be 0. And this is 0. And also this is 0. And let's distribute it. Okay. So I'm going to take minus 36 times 6. Yeah, I'm right here actually. If I write it, that will be better for you. Distribution from B to A, that will be minus 36 times 6 over 11 times minus 1. That will be 19.64. Okay? And 19.64. And distribution from distribution BC, that will be minus 36 times 5 over 11 times minus 1, and that will be equal to 16.36. 16.36. Now I cannot make the carry over to the left and right side, because it's closed. I use the modified formula and it's closed. For this one it's also closed. I cannot make any carryover here. There is no any carryover from to here. So actually the question is solved. So sorry. So now let's find the moments. What I did when I find the moments, I am going to take the summation of from the fem until the last row. Okay, last row. This is the last row. Okay, so total moment that will be 19.64. And then when I take the summation of this both, minus 36 plus 19.36, that will be equal to minus 19.64. Okay, so this also be minus 19.64. And now you can see I have my moments. So let's find the shears, and then we are going to draw the diagrams. So the first shear, actually I can make it here. For the shear, I have A, B, okay. This is going to be B left. And I have a moment at this direction, 19.64. And I'm going to take the moment with respect to B. So total moment at B is equal to 0 at this direction. that will be minus 19.64 and minus VA times 5 is equal to 0. VA will be equal to minus 3.927. And of course, the VB left will be equal to that number, but it will be positive of that. Okay. And now I find the both shear. So let's write it. So let's do it for the other member. So this is going to be the other member. From that will be VB right, and this is going to be VC. So VC. And I have a moment also here, 19.64. I have a force, it acts at this location, it will be 48, okay? This is 3 as the length. And I'm going to also again write the total moment at B is equal to 0. And this direction is positive. And 19.64 minus 48 times 3 plus VC times 6 is equal to 0, and VC is 20.7. Total Fy is equal to 0, because you know if I find the VC, I have to find the VBR also, VB right. So that will be 48 minus 20.7 minus VB right is equal to 0, and VB right will be 27.3 kilonewton. Okay. Now we find all shears, and now let's draw the shear diagrams and the moment diagrams. So I'm going to make them separately. It will be better to understand. You can you can lie down your column, because you know this is the column part from A to B. Okay, it will be easier for you to understand. And now I have a shear at A is minus 3.927. Okay, so we can say 3.93. Okay, 3.93 minus, I will decrease, and I will go the same amount, 3.93. I will go with the same, sorry. I will continue, with the same amount. And when I came to VB, the VB left will act as 3.993, and it will goes up at this direction. And so now I have it also. I solved the shear for the first part. And let's draw the shear for the second part. I'm going to draw the moments. And for the second part, that will be something like that. Also, sorry, this is 5 meter, this is 6 meter, because we will need it. And now I have at VB right. What is VB right? VB right is 27.3. So I will goes up at 27. Okay, 27. At this 27.3. And I'm going to decrease because the force as act distributed. So that will be decreased as triangular. I'm going to decrease as 48 triangular from that until this point. Okay. This is going to be linear actually, but I cannot draw it well. Sorry for that. But this is going to be linear. Okay. This is going to be 20.7. And now I draw the other shear diagram. This is B, this is C, And now let's draw the moment diagrams for the both. So the moment diagram will be something like that. Now you can see there is no any moment here, so I'm going to start with 0. Okay, and the moment will be the amount of this area. It is downward, so I'm going to read down. What is this amount? this amount of area, that will be 19.6. Okay. So for the next part, I am going to start with 19.6. It is still at the bottom, so I'm going to go on with the bottom. And I'm going to increase at this amount of area. What is this length? Actually, it comes from that. Normally, we are going to say x. We are going to minus 6 minus x. So x over 6 minus x is equal to 27.3 over 20.7. And you have x here as 3.41 meter. Okay. So I'm going to raise at this amount. It will be 27.3 times 341 over 2. And this is my value. What is that? 1 second, I'm going to calculate quickly. For example, this is what? This is 46.55. Okay. So now I have this value. I am going to increase at this amount. Okay. When I increase at this amount, I'm going to reach, for example, at this point, and this will be 26.9. Okay. This is going to be 26.9, and I'm going to decrease at this amount of area. You know x, if you take subtract from the 6, you're going to find this length. When you multiply it with this length, of course, and when you divide it 2, you are going to obtain the which amount that you are going to decrease. Okay. So then I decrease, and I'm going to stop at 0 because there is no any moment at A, and also at C, because they are pin connection. At the pin and the roller connection, there is no any moment. Thank you for watching. If you like and if you want to see more of the videos, please subscribe and share with your friends. Thank you for watching me. See you later for the next question.